So here is a little recap on all the things we've learned thus far about logarithms. So the first thing you must be able to do is solve by making common bases. So examine the problem and try to figure out what base they could both be turned into. These problems can both be turned into a base of 4. The left-hand side already has a 4. And the right-hand side, I know that this is 1 over 4 squared, but if I bring 4 upstairs, that would be a negative 2. If the bases are the same, then the exponents are the same. I'm going to move the 3x's to the right, add 2, make a 9, x equals 3. Okay? The second thing you must be able to do is graph exponential functions. I'm going to graph a basic y equals e to the x. E to the x is exponential growth. Exponential growth because the base is more than 1. It's 2.7. So the special points would be 0, 1, 1 comma 2.7, and then negative 1, 1 over e. So here is the basic exponential growth, e to the x. It's a dotted one because that's not the actual graph. Now I was asked to do negative e to the negative x. Out in front, this is a reflection over the x-axis, and a negative here by the x is reflection over the y-axis. Oops, A-X-I-S. So I have to do a double reflection here. If I reflect this down over the x-axis, it's going to go like this. Okay, and then if I reflect over y, it's going to go like this. Negative 1, comma e, and it's going to be like this. Asymptotic to the positive x-axis. Okay, how about domain? Whenever you're doing a log, you have to have the of be greater than 0. So x minus 4 is greater than 0. X should be more than 4 for this logarithm to work. It does not matter what the base is. The of has to be greater than 0. Okay, here's another domain. It says x squared minus 25 has to be greater than 0. And this is one of those cases where you have to draw a number line. Okay, and when do you need a number line? If number 1, there's a denominator with an x in it, or number 2, it's x squared or higher. In this case, I'm going to factor in x plus 5, x minus 5, greater than 0. On the number line is plus and minus 5. They're open bubbles because it says greater, and then you're going to test the sections. Another approach to this, when we studied quadratics, was drawing a graph. So if you look at this graphically, the parabola would be opening up, touching at negative 5 and 5, and it would be going like this. Now negative 5 and positive 5 are open bubbles. It wants to be greater, and so we get this piece and this piece. So if you're more of a parabola person, in this case only it's a parabola, or a number line. So the answer is from negative infinity to negative 5, union 5 to infinity. What I love about this chapter is a lot of the rules from the past chapters are being used. So it's perfect review for the final. All right, let's write something in exponent form. So you do a log circle. When you have a log and you want to switch to exponent, you use the log circle. Use the log circle. 1/4 to the power of negative 3 equals 64. It says write in exponent form, so I will. If I evaluated that, I would get 64. To write in log form, you should start by writing the words log and the equal sign. And you put the little tiny base down low. So the base is 6. And then when I do the log circle, I would go over here to the power of, and it's negative 2, equals the fraction 1/36. That's in log form. Using the change of base to evaluate, I don't have a log base 8 button on my calculator, so what I will have to do is log of 27 divide by log of 8. I'm going to choose the common log with a base of 10, but you could also choose the natural log with a base of e. Does not matter. The calculator answer will be the same. So log of 27, close the parentheses, divided by log of 8, and the answer is 1.58. 1.58. Okay, and then we did do a lot of solving using the log rules here. So here is an equation I have to solve, and I have to use the log circle. 42 to the power of 1 equals x squared minus x. Oh, a quadratic. I'm going to have to move everything over to one side and try to factor this puppy. If I can't, I'll have to use the quadratic formula. But, oh, I believe it does factor. We have x minus 7 times x plus 6. So the answers are x equals 7 and x equals negative 6. Whenever you're doing a log problem, we should probably make sure that the of is not negative or 0. I think 7 is going to be okay. What about negative 6? Negative 6 squared is 36. Oh, both of them are good. Both of them are good. You check in the original equation. All right, number 9, solve using log rules. The base there is e. I'm just going to write the little e in there. Let's see, I can't do any baby algebra. Maybe what I'll do is take the 4 and bring it down in front as a power. Okay, I think bringing the 4 down is going to make this problem a lot easier. Okay, instead of e to the 28th power, maybe what I'll do now is divide both sides by 4. Okay, because that's just a plain 4 divided by 4, and that makes just a 7 over there. So natural log of 6x equals a 7. And now do the log circle. E to the power of 7 equals 6x. Okay, I'm trying to solve for x, so the only thing left to do is divide both sides by 6. So x is e to the 7th divided by a 6. Okay, we'll just leave it like that. It's exact. If you're curious about the decimals, you could type it in, but that's the perfect answer. Number 10, solve using log rules. If you have a problem where there's a log on the left and there's a log on the right, and the base is of 6 and the base is of 6, you can just isolate and look at the ofs. If logs are equal, then ofs are equal. X plus 8 equals 2x plus 3. And now it's just a linear equation to solve. X equals 5. Let's make sure this is okay. If I take 5 and I plug it in, that of is positive, and that of is, yes, positive. Both good. Number 11, okay, similar to what we did today in class, there are 3 things. So I can't just set the ofs equal. Okay, there's 1, 2, 3 things. There's a lot of logs. Maybe what we should do is combine both of those logs into just one log of a base 3. So you're going to have 1 log. We still have equals 4. And the ofs are going to get multiplied. X squared minus 24x. Make sure you use parentheses so all of that stuff gets in the log, in the of. And when you get stuck in log form, you go ahead and do a log circle. 3 to the power of 4 is 81 equals x squared minus 24x. 0 equals x squared minus 24x plus 81. And now we're going to have 0 equals x and x. Let's see, 27 times 3. And I'm going to make the 27 negative, positive. So x is equal to 27 and x is equal to negative 3. Let's make sure both of these are okay. 27 is okay in both of those ofs. -3, ooh, not so much. -3 is not going to work. That's extraneous. The only answer you'd put on the answer line would be 27. Okay. And the last one here says solve using log rules. So I noticed that there are 3 things again. And what are we going to have to do? I can't set the ofs equal because of the 3 things. I think I want to get all the logs onto one side. I'm going to put all the logs, let's put this log on the other side, log base 6 of x minus 5 plus log base 6 of x equals 2. All right, now there's too many logs. I'm going to combine 2 logs into one log. Log base 6 of x squared minus 5x equals 2. When you get stuck in the log, you're going to go ahead and use a log circle. 6 to the power of 2 is 36 equals x squared minus 5x. Quadratic needs everything moved over to one side. Minus 36, and I'm going to try to factor this. So 0 equals, let's see, 9 times 4 minus 9, positive 4. So x equals 9 and x equals -4. Are both of those answers okay, or is one of them extraneous? 9 will definitely work. Oh, but -4 right here is not going to work. So -4 is extraneous and 9 works. What I really want you guys to do is spend a lot of time now, and on the next couple of pages, we've got 3 pages here of multiple choice questions. It's a practice take-home quiz. I need to see all of your work in the packet. Make sure you try all these problems and circle the one correct answer. Pretend like this is a final. Okay, good luck, and I can't wait to see your work.